Hi, and thanks for the opportunity to tell you about Intel's products and technologies. My name is Mike Kendrick. The team that I'm in covers Intel's HPC product portfolio. We work with end users, designing customers, and other ecosystem partners to test our theories, understand the market needs, and influence Intel's products to best meet the needs of high-performance computing. I'm going to talk about some of the challenges faced by high-performance computing world and what Intel is doing to meet those challenges. I'd then like to spend the bulk of the 15 minutes walking you through the product announcements that we made during the second quarter of 2021 that amount to a complete platform upgrade for systems purchased this year. Lastly, I'll spend some time talking about our upcoming platform ingredients for the next complete platform upgrade planned for 2022. As you are aware, the industry now has an assortment of compute accelerators entering the market and an assortment of CPU architectures and memory architecture options. This comes with an assortment of developer tools and application developers designing for specific hardware they believe run their applications the best. However, that is just for now because it's likely that the leading hardware for an application will change over time. Another trend to expansion of compute targets and associated tools is the explosion of data. This is driven both from the ability to store more data than ever before, but also to unlock the potential of leveraging that data across applications that users previously didn't seem possible. The above trends are creating both an increase in diversity of compute node types and storage bottlenecks, but are also driving a continuing trend of high power consumption over time. And so I think that the ability of a data center to optimize for the increasingly diverse needs of its users has reached a limit, but cloud providers have emerged and can fill the gap of those needs not met locally. Living up to its reputation, Intel is driving ecosystem open solutions to these problems. For example, to address the diversity of developer tools, Intel is working with OneAPI to create a single programming model for all computing. Intel has enabled an open source distributed asynchronous object store solution to avoid bottlenecks between storage and compute for the workloads of today and tomorrow. Intel has developed a novel new power management capability that allows data center to realize energy savings while minimizing performance impact. And lastly, focusing on the ongoing migration of applications to a cloud environment, Intel is working on solutions such as select solutions, while also providing CPU features that enable building a more data secure environment within cloud service providers. I mentioned we had a full portfolio launch in Q2. At the center of this is the third generation Intel Xeon scalable processor, which I'm excited to say signifies the data center's move to Intel's 10 nanometer process to offer great strides in performance. At the same time, to help process everything, we have launched our Agilex FPGA family, which is shipping today and takes advantage of PCIe Gen 4. To store more and access it faster, we have released releases of new Optane SSDs and Optane persistent memory technologies, as well as 3D NAND drives that support the platform. And to move that data faster, Intel launched the 200 gigabit E 800 series Ethernet adapter, again taking full advantage of PCIe Gen 4. To enable this portfolio, the new ModSim Select solution using OneAPI and the HPC platform specification version 2.0 running on CentOS 8.3 were all launched. Since the processor is the centerpiece of this platform launch, let's dig into it a little bit more. Our third generation Xeon scalable processor features up to 40 cores and delivers up to 20% gen-on-gen improvements in instructions per clock. This is true IPC improvement as it's measured on the same core count, frequency, and compiler. I'll be covering more about the performance on the next slide. But before we get there, I want to point out the useful features this processor implements to address today's energy and security concerns. Intel's Software Guard extension offers tools for the cloud service provider to help protect their data while in execution. And Intel Crypto Acceleration is there to gain back some of the time spent encrypting and decrypting data as it moves within the modern compute infrastructure. Speed select technology can be used to reconfigure a single processor on the fly to a different design point. For example, fewer cores running higher frequency. Now you can tune your CPU configuration to best meet the needs that the workload that you're running right now. And another mode of speed select offers fine-grained control over CPU performance to optimize power efficiency and can be accessed using GOPM's open source tools, which are posted to GitHub. Here, you'll notice benchmark performance is excellent generation on generation, but what users really care about is workload performance. And here you see the huge gains this generation of processor provides, thanks to a focus by our architects on speeding up what really matters to users. The AI performance, shown on the bottom left, is on top of the incredible multiple time performance increase that was offered by the previous generation implementation of deep learning boost, meaning for most inference needs, an expensive accelerator is not necessary. Looking a little more closely at our Optane products launch, you can see on the left that our data center persistent memory now provides 32% higher bandwidth than the prior generation and up to 6 terabyte total memory per socket. Our Optane SSDs are outperforming our own NAND products by up to 26x and up to on IOPS per gigabyte and up to 13x on average latency. Multiple HPC vendors have already taken advantage of the capabilities of these products. These companies have accelerated their software stack by incorporating PMEM and Optane SSDs into their software stacks. To the right, you'll see our Deos initiative. This is an open source object store built to optimize data exchange across computer nodes. Our Deos solution has been updated to add support for third generation Xeon scalable processors and the PMEM 200 series memories. Intel is offering commercial L3 support through integrators and has a partner enabling program running. To move data faster, Intel offers silicon for an OFA compatible end-to-end solution with comparable application performance to other fabrics on small clusters, but at a significantly lower cost. And Ethernet offers end-to-end packet tracing and Intel Deep Insight Network Analytics software. This software provides visibility into how packets move throughout the fabric as they move through the fabric without duplicating packets and sacrificing network performance. It will be easier to tune and debug your fabric, thus improving the resiliency of your network infrastructure. And for large system HPC fabric needs, Intel has strong partnerships to ensure both the Mellanox ConnectX architecture and the Cornelis OmniPath Express architectures run best on Intel. Next, I'd like to move on to our next planned platform. At the center of the next platform, to process everything, is a major processor upgrade codenamed Sapphire Rapids. Sapphire Rapids processor is built on Intel 7 process technology. And you'll see a full platform available with both PCIe Gen 5 and DDR5 memory, and the PonoVecchio compute GPU, targeting specifically at the compute acceleration market. It also supports the next generation data center persistent memory to store more functioning at DDR5 speeds. And to move your data faster, we will also roll out our 128 port Tofino 2 switch silicon, again validated with our Ethernet 800 series Ethernet adapters and Ethernet fabric suite. On the software front, we will be updating Intel OneAPI tools designed with heterogeneous computing in mind with a new release. Sapphire Rapids will be the next generation CPU, and some of the key features being brought to market include PCIe Gen 5 for direct attach 400 gigabit fabrics and discrete compute accelerators, the Open Standard Compute Accelerator Link, or CXL version 1.1, setting the stage for future coherent GPU attach and much more, and DDR5 with CrowPass Intel Optane persistent memory support. In addition, we will move to the next generation of CPU integrated AI capabilities with our advanced matrix extensions. And as you may have read on the trade websites, I can now confirm that we will have SKUs of Sapphire Rapids that support high bandwidth memory for high bandwidth sensitive workloads like fluid dynamics and crash simulations. We will support the same modes some of you may have coded for in the past. HBM only mode, allowing one to save the cost of DDR through the cluster, flat mode for direct software control of what is placed in what memory, and cache mode to simply accelerate existing workloads with no changes needed. Our groundbreaking XE architecture continues to hit execution milestones. We have launched Intel Server Graphics SG1 and sampled the next silicon. And now PonoVecchio has powered on. PonoVecchio is the next XPU release and specifically targeting HPC and AI. PonoVecchio leverages Intel's leading packaging technology, taking EMIB used throughout Intel and Foveros technology used by our client processors to create a leading XPU offering. Using these technologies, 47 tiles are integrated into a single package in a diverse combination of more than 100 billion transistors. To deliver this technology to market, Intel has created multiple form factors for easy adoption in the industry. Our by4 OCP compliant GPU modules are built to target HPC, providing the right balance of CPU to accelerator compute. Our by8 OCP compliant GPU modules are built to target deep learning training, where the compute is more coarse-grained and well adapted for accelerators. You can see on the right what each of these would look like at the system level. And lastly, we will also have PCIe add-in cards available. As mentioned previously, Intel is supporting the industry standard OneAPI open source initiative that provides a single unified programming model to simplify cross-architecture development. This gives customers the freedom of choice in the hardware they purchase while realizing the full hardware value provided by compute suppliers. With Intel OneAPI implementation, you can confidently develop performant heterogeneous HPC and AI code for Intel's compute devices, while the ecosystem momentum spanning across ISVs to silicon vendors ensures that you maintain the freedom of choice in hardware in the future. So our full platform launched this April and another coming next year. Intel processors remain the foundation of HPC and AI at the center of a portfolio of hardware and software that Intel delivers for today and tomorrow's challenges. Thanks again for giving me this time to walk through our HPC portfolio.